coding some VOD.
The problem is generate parenthesis. Let's analyze this problem. We have been given n pairs of parentheses and we need to write a function to generate all the combination of well-formed parentheses. Let's evaluate this example 1. In this we have been given input as n equals to 3. That means the total number of pairs are 3. These 3 pairs actually means that we have 3 open bracket and 3 close brackets. And in the output you can observe that we are receiving the valid parenthesis. Now we will be discussing the concept for solving this problem. The idea is to use the backtracking. Why backtracking? Because in this we need to generate all the possible type of combinations. And whenever we need to generate all the possible type of combinations, we prefer to use backtracking. It's a part of recursion. Next, we will be maintaining an empty string and the two pointers open and close. The open and closed pointer will represent the number of open and closed parentheses remaining to be placed. At each step, there will be two choices, and whenever you see choices, it means recursion. Now, the first choice is when your count of open are greater than 0. In that case, you will be adding one open parenthesis and recursively calling the function with one less open parenthesis. What does this mean? Suppose this is the recursive call of the function and you are having a string here, and if the condition is that open count is greater than 0, so in this case you will be calling this function that there will be a string and you will be adding one open bracket to it, and you will be decrementing one count from the open. Suppose here there will be any number of count and you will be decrementing it by one, and you will keep the close count as same. Now the second condition is if close is greater than 0. What does this mean? If close is greater than open, in this case you will be calling the function for string plus close bracket. In this case you will be calling the function recursively for string plus close bracket. Open count will remain same and you will decrement the count of close by 1. There may be one question that might be arising in your mind, that why don't you write here close greater than 0, and why did you written here close is greater than open? I have written close greater than open here in order to maintain the validity of valid parenthesis. We need to maintain a condition that we need to generate valid parenthesis. In order to generate valid parenthesis, it is necessary that the count of close should be greater than open. And you cannot use close greater than 0 because it will generate invalid parenthesis. I will show you in the recursion tree how this problem is occurring when close is greater than 0. Now we will continue this process until open and close become 0. So these two were the recursive case for this problem. These are the recursive case for this problem. Now I will be discussing the base condition. That is, if count of open becomes 0 as well as close count becomes 0, at this point you will have a valid string of combination, and that would be pushed in the result. Result is a vector that we have to return. So you will be pushing back the string that you are maintaining in each recursive call. It's time for looking and evaluating more deeply through recursion tree. For making the things simpler, I have considered an easy example for better understanding of recursion tree. So initially we will be maintaining a string that is an empty string and result vector, that is this is actually the result vector, In this, we will be pushing these string. These are the string that will be formed. Other than this, we will be maintaining the two counters, that is open counter and close counter. So initially, since input is given 2, so it means there will be total 2 open brackets and 2 close brackets. And this string is empty and result is also empty. This is a vector. Now we will be calling the function. Suppose the parameters are an empty string, the count of open, close, and the result. Here we can directly observe that the count of open is greater than 0. So we will be following the first condition that says that you will be adding open bracket to this string, and decrementing, you will be decrement the count of open bracket by 1. Close bracket count will remain the same. This is open, count of open, this is count of close. At this position, we have the count of open bracket as 1, which is still greater than 0. So now the string will become this. We have added one more open bracket and we have decremented the count of open bracket that was earlier 1 to 0. Now the close bracket count is 2. Now at this point you can observe that open bracket count is 0. So the second condition will follow here, that is close bracket count is greater than open. In that case we will be adding the close bracket now. So we have added one close bracket and we have subtracted 1 from the count of close bracket. Now again we can observe that the count of the close bracket is greater than open bracket. Second conditions follow and we will be adding one close bracket and decrementing the count of close bracket. Earlier it was 1, now it will become 0. So what is this? Now we have reached the base condition. At this point we have reached the base condition and this is our generated string. We will push this string into the result. Into the result vector we will push this string. Why it is base condition? It is base condition because you can observe here that the count of open is also 0 and the count of close is also 0. And after pushing the required string, we will be returning back the flow. What is meant by returning back the flow? That is, we are not returning anything, we are returning void. So it will return. We will write here return. So it will return the call back. So at this point, you can observe both conditions are satisfied. Condition 1 and 2 both are satisfied. Now we'll move back. So this is moving back in the recursion is called backtracking. At this point also, condition 1 as well as 2 both are satisfied. Now we will return to this. At this point, we will observe that condition 1 is satisfied, but condition 2 is still not satisfied. So we will now try to satisfy it. Now we will call the function that we will check. First we will check that the count of close is greater than open. It is 2 and open is 1. So we will be adding close bracket to it. And open bracket count will remain same. Close bracket count will decrement by 1, that is 2 minus 1. And that is 1. At this point, we can observe the open bracket count is now greater than 0, so condition will follow. So we will be adding one open bracket and we will be decrementing the count of open bracket and close bracket count will remain same. At this point, open bracket count is not greater than 0, therefore condition first is not satisfied. We will be satisfying here condition 2, that is you can directly observe that close bracket count is greater than open bracket count, because close bracket count is 1 and open bracket count is 0. So we will be adding the close bracket to the string. So we have added it, and we will be decrementing the count of close bracket by 1. Therefore, again, we have reached to the base condition where the count of open and close has become 0. And we will be pushing this string to our result. And we will be returning the flow. So it will backtrack here and it will observe that both conditions are satisfied here. Condition 1 and 2 both are satisfied. It will return here. Now it will check here whether both conditions are satisfied. Currently here only one condition is satisfied. Now we will try to satisfy and check whether second condition can be satisfied or not. So as you can observe, the count of open and close are equal, that is 1, and there is no such condition that could satisfy this, so it will not move further. Since count of open bracket is equals to the count of close bracket. So there is no such condition. Now the function call will return back to this condition. After this, we can observe now second condition is also satisfied for this call. Now it will backtrack to its parent call. So at parent call, we can observe till now only the first condition was satisfied. Now we'll check whether there is any chance for satisfying the second condition or not. As you can observe, the count of open and close brackets are equal here, and there is no such condition that has been explained in the concept. So we will not be moving further. Now we will be discussing about the code. As you can observe, we have been given a function that is generate parenthesis, and this function is accepting a parameter n, that is number of pairs of brackets. In this, since we need to return a vector of a string, so we have created a vector of a string named as result, and we are calling our user defined function with a empty string as parameter, n as the number of open bracket, n as the number of close brackets, and the result which is initially empty. Now coming on to user defined function. So let's first discuss about the recurring case. In recurring case, we have the two conditions. One is when open is greater than 0, the count of open brackets is greater than 0. In that case, we are calling the solve function recursively. We are adding the open brackets to the string and subtracting its count, while close count remain the same. In second condition, when count of close is greater than open, we are adding close bracket to the string while decrementing the count of close by 1. Open remains the same. Coming on to the base condition, it is when the count of open as well as count of close is 0. In that case, we are getting a valid string combination that is being pushed to the result vector, and control is sent back to the parent. From this solve function, which is a user defined function, we will have a combination of strings which are valid, and that will be returned as a final result in the given function.
Like, comment, subscribe to Coding Samvad.